All right. See if this continues to copy over to the disk. I forgot to transfer my stream recording from Saturday. So I'm in the middle of doing that while we're streaming. So hopefully it doesn't interfere too much because it's absolutely running right now. Okay. So, one of the things that I wanted to do first, we're going to do Rust language workshop stuff today. Specifically, I think we're going to cover error handling. We're going to cover structs and enums, and hopefully get into like anyhow and library versus application errors and things like that. Maybe some this error, etc. But one of the things that I wanted to bring up is I continued to play with the async stuff that we were working with on, I want to say Saturday. Let's run this cargo run bin terrain multi-threaded. So this should be basically the same demo that we ended up with. We should probably turn the FPS counter off because it really doesn't matter right now. But basically a bunch of terrain. It gets thrown over to Tokyo in a Tokyo thread or whatnot, and is just constantly generating new terrain for us to get into. You can see it generate right there. It was pretty obvious. There's no real spikes because we're doing this async, which means it's off the main thread, so we're not blocking the frame. We can just keep continuing and it will, show up when it's done. The big thing for the async stuff that we were doing on Saturday is that on stream, I was not starting up a full Tokyo runtime. So I wasn't letting like Tokyo handle the multi-threading, right? But you can absolutely do that. And that looks like this. So we've got a derived resource, Tokyo runtime, with the runtime inside of it. This is just going to get a resource shoved into our Bevy application. In our startup function, we initialize that runtime. And then spawning new tasks is as easy as doing runtime.spawn. So we've got this spawn terrain. We need to pass the world ID that's required. But we've got this spawn terrain function that's down here. It takes the world ID in the chunk position, uses async access. It's an async function. We do our world access from the async world to do our checks to see if we should generate. We do generation in the async function outside of that async access. And then we do like another async access to like reinsert the mesh and spawn it at the end. So this is a significant difference from the approach we were taking on stream, which was very much just taking the demo example content and shoving it into that's the original, that's why. Shoving it into like its own thread, starting a single threaded Tokyo in that thread and then blocking on it with the spawn terrain. So we talked a little bit about the async stuff and how you could run your own like full Tokyo runtime, multi-threaded, etc. And this is actually doing it. So this is really nice because then we do this again later. So we insert the resource with the Tokyo runtime, and in some other system that's running whenever. This is a managed chunk system. Managed chunks runs an update to like, manage which chunks are actually spawned in around the player. We grab the Tokyo runtime from that resource. We decide what we're going to do, and for each chunk position that we're going to do, we then spawn a new spawn terrain async in that thread, let Tokyo manage everything, and it will handle kind of doing the access back to the Bevy world, which is really, really cool. This is all pushed up on GitHub under the Rust Adventure org as usual. So anybody who's interested in that can go check it out. Let's see, quick start. I've got about 4,000 words in this Rust language doc right now, which is not a trivial amount of words. How do I get this sidebar off? Hide sidebar. That's such a weird, like, check to hide sidebar. Why? Anyway, whatever. Double negatives. So we've got quite a few pieces of content done here. We've got everything through installation, right? Installing Rust or not installing Rust using Rust Playground, something like that. Just check my file stuff over here, see how it's doing. Cool. 68% complete. So we've got Rust installation or not installation. We've got a why Rust section. Rust up. We talk about Rust up. We talk about cargo. We talk about the tool chain and all Rust analyzer. Jump into creating a new project. Do like the basics of Hello World. Cover that Rust is an expression-based language primarily. We then jump right into ownership, which we then cover with a couple of different examples. And how do you work with ownership? You can clone stuff. You can move the ownership around. A single variable owns that data, so you can just keep giving it to a new variable or a new function or whatever. Or you can use references. So it's like use references, use cloning, or move the data. Then we talk about deref coercion and slices because we have a function. I guess this is too small for anybody to see, so maybe I make this a little bit bigger. Deref coercion and slices, which is relevant because we're working with a vec at this point, and a lot of the functions on vec are actually functions on slices. And it's important that you can deref a vec to a slice if you have a shared reference. Talked a little bit about subslices, introduced ranges, owned versus sliced values. That's TK for a heading change. We talk about string and string slice, vec and slice, path and path buff, which I think drives home the point that there are kind of multiple variations of like the thing that contains the own data that you can grow, that you can insert new things into, and then the thing that like is just a static view into that, or static might be the wrong word, but like is just a contiguous view into those structures. We finish up the ownership section by talking a little bit about copy semantics. There's a little bit of explanation here that I need to rewrite, but generally speaking, this is the difference between, say, like a struct that holds a bunch of vec data that you don't really want to like implicitly clone, and a bunch of like I32s, which are typically used like just as the number in an equation. So like if you're doing 5 times 5, it doesn't matter whether that is like a bit copy of a 5 or not. So now we're up to structs and enums and error handling, and then some dependency usage. Structs and enums are going to be talking about, like, I want to talk up here about sum and product types, but I don't want to use those words because nobody knows what they mean unless you are already, unless you're already familiar with something like a functional programming language like Haskell, but very few people are, and those are scary concepts in that sense. So what I really want to say here, I think, is let's pull our actual doc up so I can start writing. What I really want to say here is like something about defining your own data types. Something about like associated functions, right? Impl blocks. We haven't really talked about traits yet, right? We talk about traits later. So down here, I will leave like default and stuff like that, or like impl trait for type, right? We'll talk about those kinds of things down here. And in structs and enums, we'll leave it as kind of like owned data. So like owned data is easier to work with. I don't want to say don't do XYZ or whatnot. I kind of don't want to be like too prescriptive here, but I do want to suggest that if you are doing something like, let's pull this over here, give us a little bit more space. Let's see, if you're doing something like my new struct here, right? Like struct my content. I don't know what's going to be in here. And this is like, I don't know. It's a vec of some stuff. I don't know. It's like the sections in a markdown document or something, right? Vec of like strings. This is very easy to work with, right? This struct owns its content. It owns this vec. The vec owns the strings. Like this, everything here is owned by my content. So if we create a my content, we get rid of this stuff. And we create like my content. We'll fill struct fields here. Rust Analyzer, super useful for things like this. So then we've got, oh, I don't know, section 1, .toString, a second .toString, like a third .toString. So we've got this struct here, and now new content is entirely kind of owned by that variable, right? We don't have a debug implementation, so we'll throw a debug implementation on this for now. Derive debug, so we're deriving an implementation of debug for my content. If you have Rust Analyzer, you can expand this macro recursively at caret, and it will show you literally the code that gets generated. If you're ever curious about what a macro is doing, derive macro or regular macro or otherwise, expand the macro, look at the code. This is something that we'll cover in like the traits section, which is that these derive, or maybe not in the traits section, I don't know, maybe in the macros section. But basically macros are code generation, right? So here you can see that it is a fairly straightforward implementation of debug. You've got your, destructured struct here. It is a debug struct with the name my content. It's got a field name sections. You pass sections in and then you finish. And like, this is the same debug for basically every struct you'll ever write. It's not for everything. Not everything will have a debug like this. But for like, 99% of your stuff, this is what debug looks like. So writing all that is annoying. And that's why we have debug macros or derive macros. So it's easier to work with this because if we want to mutate something in here, right? We say let mute new content, and then maybe like new content, like dot sections, like 0, right? Equals something else, right? Dot toString. So we're working with owned types. We're creating a new string. We're putting that new string into new content. And if we run this, we get my content with sections, something else, a second, a third. This is conceptually easy. Like the variable new content owns all of this data, including everything in the vec, etc. If you want to reach into the vec, if you want to give mutable references out to the vec, like if we want to write a function here that does, oh, I don't know, we'll just call this items. And this will be like a mutable slice, because I think we've covered slices here already. Like a mutable slice of strings. And then like items dot 1 or items 1 is going to get set to, oh, I don't know, another one. Like something like this, right? And this is no longer prints path. This is like modifies 1 or something. These aren't necessarily the examples I'm going to use. I'm just talking through kind of what we're going to do here. So here we've got modifies 1, right? And we can say we have new content. We can pass in new content dot sections because we have access to it. We own it. And this just works, right? We pass this in. because this like new content is the owner, we are passing in an exclusive reference to this function. This function can take that exclusive reference, do whatever it's going to do, and then release the exclusive reference, and then everything works as you might expect. If you have something else, which is like someone else's content, and this is a slice of strings, right? This needs a lifetime now. Now we have to talk about lifetimes. This can get very confusing for people. So if we have someone else's content and sections, right? And we put in new content dot sections, like let's take the first item on. So we're dropping kind of like that first item and referencing it. Now what do we have? We have a struct whose data is not owned by the current struct, right? So if we debug this out, it should be fine, right? We've got someone else's content has those two, a view into those two items, and my content has the full set. This stores a shared reference. So if you start off trying to use shared references everywhere, right? This is a shared reference to a string slice. Like, how do you get at this to mutate it? Is kind of a like an interesting question, right? So if we go like someone else's dot sections, like this is like, okay, can't borrow as mutable. Fine, we need a mute here. You follow the things and whatnot. We need a shared reference here. Cool, we're passing in all our shared references. Now we've made two fixes already, right? As a newer rustation, you've made two fixes to your program already. You're trying to figure out, okay, well, I can't borrow this as mutable. Why not? Right? And the why not is you stored a shared reference here. And this is a reference to this content. And this is a shared reference. So how are you going to modify that? Right? Like you're trying to mutate this through a shared reference that really isn't allowed to be mutated through. So these kinds of errors can get very confusing very quickly, especially if you're not familiar with lifetimes, you're not familiar with the concept of like variables owning things. So the general advice for people who want to do things like this is like, if you are a new rustation, then you should use owned data in your structs, generally speaking. Now, there are valid reasons to do shared references and stuff like that in structs. We are probably not going to cover them in this document. We might cover them later. Wow, that was a really weird Chrome switch. But if you're doing something like parsing, right? And you want to do like zero allocation parsing, right? Like you're going to go through this entire document, you're going to find a bunch of stuff, and effectively what you're going to do is what we just saw, right? Where you have some input, which in this case isn't super interesting. It's just like a hard-coded string. But that input is going to come from like a file. It's going to live in a string somewhere, right? Capital S string, owned data. Then you can run this parser because this parser has shared references to all of the input. And if you're trying to keep references to things that exist in that string, then everything can be a reference back to that original input. And thus you can do this kind of like, we're just going to store shared data rather than allocating anything. Now, if you create new data inside of these parsers, then yes, you have to like, a color is whatever. It's like 3 U8s or something in this example. So we end up with like 3 additional U8s. But if all you're doing is storing these string slices or like bits of these string slices from these parsing functions, You can totally build up an entire structure that is like zero allocation. So this is super useful, and it makes sure that you're not like accidentally modifying things that you've borrowed in different ways and whatnot. But it can be very confusing very quickly, is really kind of what I'm getting at. Right. And like this is super confusing too, because like, oh, but I thought I passed in an exclusive reference to someone else's content, right? I thought this was going to give me access to mutate this. Why isn't that true? Well, the type isn't a mutable reference, right? If the type is a mutable reference, then you can mutate it. But like you kind of have this additional control point where if you are using references and structs, those things have to reference own data that lives somewhere. So if you are someone who's building your own data structures, using owned data is a very clear mental model. This one variable owns all of this data, and I don't have to worry about sharing references to it through other structs, because those structs can get passed around and it can get kind of confusing as to what is owned by what. But this is the general concept, right? The conceit of this section is there are structs and there are enums. Structs are combinations of all of the content that they can hold. Enums are a choice between a couple options. You can implement traits for either of them and whatnot. Result and option are enums, for example, but there are also other structs. Everything in the standard library is effectively, wow, I need to pull this Chrome window all the way back over. That is way too much tabbing to do. Let's get out of some of these tabs. So like hash map Rust, right? We go into collections. This is a struct, right? A lot of the collection types and other things that you're going to use are structs and enums. And the way that you build functionality up, if we go into the source here, is you've got this struct. It has some stuff. In this case, it uses another struct, which we're not going to talk about. Uses some generics, which we haven't reached in this particular educational example yet. But then you impl block and you're like, oh, here's how you create a new hash map empty. Here's how you create one with capacity. Here's how you do X, Y, Z, build a hash map with a hasher, build, etc. There's also functions that are like, give me an iterator over all of the keys. So that might look familiar if you've been into the previous streams, because vec is also a struct, right? And I think what's really interesting, since we're talking about this, is that string is also a vec, which is also a struct. So like fundamentally, when you say that you have a string and it's kind of like a vec of U8s, this is the definition for string, and it is a vec of U8s. Right? It's a struct called string with a vec field that's private. That is a vec of U8s. And the only way you interact with this is through the other functions and the other, the impl blocks and things like that. You never set this vec directly, right? You can't access this vec field. So that's kind of what I want to get across in this section, right? I don't want to say Rust has 2 data types. Using struct and enum. A struct is, and if anybody has any questions, feel free to ask them. I see you all lurking. So a struct is what, a collection of fields? Is this even in the reference? Kind of. This is in the Rust book. Structs are similar to tuples. Okay, kind of. Did my file processing stop? So I'm gonna be able to disconnect this little drive, hopefully. I don't know why you can't right click eject on Windows. That's so weird. Cool. Wonderful. Delete that. So I have space on my computer, and now we disconnect the hard drive. Wonderful. Love that for me. I know Stream doesn't care, but I love that for me. I feel like calling structs similar to tuples is kind of weird. Like, yeah, tuples. I don't think we've covered tuples in this yet. Not really. Let's call this, we're in examples, right? So we want this to be in source. Oh, this is in temp. Okay, why did I put this in temp? That's weird. I'll have to go back and reconstruct all the code examples for this and put them into the source directory. This is what I want to check though. You know what's really annoying? That VS Code can't handle interacting with my operating system. RG tuple on main. Yeah, so we really haven't mentioned the word tuple yet. So maybe we do want to mention tuple here. I don't know. We didn't really spend any time talking about arrays either. Like maybe this isn't structs and enums, but this is like data structures in general. And then structs and enums are just one section of this section. Because in that case, we're going to talk about like scalars. And then we're going to talk about arrays and tuples. And then we're going to talk about structs and enums. Right. Rust scalar values, ... I don't think we need to explain what a scalar is. Right? Like if we just do like Rust scalar on the internet, it's just going to be like, oh, here's your data type section of, you know, the Rust book or whatever. Like how much do we really need to say that a number exists? We're assuming already that you know what a programming language is. So I think the only really interesting thing that you might not know is that characters exist as their own type and that integers and floating point numbers have bits associated with them, right? So bits for numbers, I32, F32, U8, etc. And then character type. And like we can mention Booleans as well. Like it has true, false, but like this isn't really an exhaustive list of scalar types either. Let's see, they claim 4, right? This is some of the like most easily findable generic Rust educational like information. Like, oh, what does a number look like in Rust? Yeah, they expand integers and floating point numbers into 2 sections, but it's like numbers, Booleans, and characters. Let's see. Let's start with numbers. Numbers in Rust come with a, I don't want to say like a bit size, but like have specific sizes. An I32, for example, is a signed integer with 32 bits available to define the number. I feel like this section is necessary because we're just saying any language. Like you could know any language, but realistically, this could be, you know, JavaScript, Ruby, Python, C, like it could be anything. And not all languages have like access to all of these numbers or number types. So we do have to mention it. So like if we go to I32 max, basically we're just going to take the I32 docs, which is this. And I32, since numbers have associated sizes, the min and max values they can represent are smaller or larger based on that size. And I32 has a minimum value of, you know, whatever. So I make sure that these numbers are actually correct from the docs rather than trying to type them out for any reason. We need the U8 docs as well. I think it's enough to say that they have different sizes and that minimum value of 0 and a maximum saying 255. 255. An unsigned 8-bit integer, which has a minimum value of 0 and a maximum of 255. I guess we put the other ones in code marks, so we'll make code marks for this as well. I feel like we have to get out of numbers pretty quickly. Like, we're not going to do a full rundown. Maybe I'll show a chart for a video, you know? But like numbers aren't super interesting other than, hey, you know, if you don't know what this number is, go look it up in the docs here. Since numbers have associated sizes, the min and max values they can represent are smaller or larger based on that size. And I32, I guess, did I say this is a signed integer? I already said this is a signed integer, so I don't think we need to repeat it. So an I32 has a minimum value of this and that. Maybe these are lists, I think. Right, just like and we'll put the links around the specific. Actually, you know what? These links don't work like that. I forgot we're in Typist. I was just writing Markdown before stream. This is link I32. And this is link U8. If I can finish my quotes here. There we go. And this is still recompiling, right? Cool. So let's check to make sure that I'm not messing this up too much. Data structures, numbers. Numbers, okay. Rust has scalar primitives as well as rich Rust has scalar primitives as well as a rich type system of custom data types that can be defined using structs and enums. We'll start off with numbers. Specific sizes, I32, yada yada. Here's a couple links. I guess we mention F32s here as well, like mention one of each type. Rather than like listing them out, just being like, hey, this is, you know, the min and max of whatever. (32-bit) floating point numbers. And F32 is a 32-bit floating point number. I guess if you don't know what a floating point is, it's not really the time to start jumping into, you know, what floating points are. We'll include a link to the docs. People will link to it if they want to. So we covered bits for numbers. I think unsigned, signed, integers. We could cover other types too. Non-max, is that in the standard library? I think that comes from a crate. Let's do non-zero. So like a non-zero U8 is probably also useful to mention here. Also interesting is the idea of numbers that use specific values to store additional data. For example, if we knew we never had a 0, we'd specify, get the link in here. We can specify a variable as a non-zero U8, right? A U8 that is known to not equal 0, which has interesting implications. In that option non-zero U8 and non-zero and U8, right, have the same size in memory because the none value can be stored as 0. I think that's the, yeah, option non-zero U8 is the same size as U8. We could show this. We haven't really talked about memory at all. This will send us to the Rust playground, so it's not a big deal. I mean, like, I understand why these are asserts, but I feel like nobody is going to, like, people want to see the output. We haven't talked about size of, or like the sizes of data structures or anything like that, so I'm not too worried about it. I think we can just mention it. We could show this on screen when we talk about it, but it's not particularly interesting. And like maybe the visual for these are the tables. This is kind of a side note. I think it's interesting. This is like a 30-minute overview. So jumping into something that's kind of like more intermediate or advanced, I think makes sense, just to be like, hey, if you want to store, you know, a U8 or whatever, and you have for some reason a reason to care about how big that is, and you want to wrap it in an option, you can wrap it in an option at zero cost. So then we'll also mention characters. Booleans, do they even really need their own section? I feel like everybody who has used a programming language will know what a Boolean is. Characters have their own representation in Rust. Character literals are defined using single quotes. We could show a demo of that, right? I don't think this will really show us anything unless we, not found in the scope. Oh, right, because character. Right, a character equals C. I think that, is there a function we can call on a character that's interesting to kind of like prove that's a character? Without getting too deep into like, oh, Unicode stuff. We could do cars. That's interesting. So like, right. Name.cars. We haven't really talked about iterators yet, but I don't think I'm really concerned about that all that much. So if we run this, this will be each character, right? Everything individually. And we can say like if character equals I or character equals I think it's more obvious to do it this way. I would usually do includes for more than one. Like a quick way to show, hey, these are characters. But like, this isn't. Given a string, we can get an iterator over the characters using, let's do a link here. We'll do link cars. In this case, we're checking to see if a character is one of two values using character literal. It's like I don't find myself actually manipulating characters all that often, so coming up with an example that's like a real world use case is like, I don't know. This is not something that I usually do. And I don't really feel like there's a generic use case for that will apply, like hit with a lot of people. In this case, we're checking to see if a character of one of two values using character literal syntax. Because car is its own type, we can't compare against a string literal. We must use a character literal. I feel like this is a little bit more verbose than we need to be. But I want to drive home that like it's double quotes and single quotes, you know? Okay, characters. Characters have their own representation in Rust. Character literals are defined using single quotes. Did this break? I wrote something incorrectly. Okay. Yada, 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 yada. Let's get the cars link. Cars, I want the method, not... And then we need the car actual type link. Let's see, let's do link car. A car is a Unicode scalar type in Rust. Let's be specific. Character literals are defined using single quotes. Given a string, we can get an iterator over the characters. I think this is just going to be a new paragraph. In this case, we're checking to see if a character is one of two values using character literal syntax. Note that because car is its own type, we can't compare against a string literal. We must use the car literal. And then why is my... That's Bevy. This is the thing. This looks like it's compiling. Did it compile? This document is already like 4,000 words or something like that. Oh, that's the wrong WC command. That's a different WC command. Yeah, 4,600 words on Rust. Meant to live within say half an hour of content. So the more paragraphs we write, the longer this takes. Okay, I think Booleans are really like trivial for people who know other languages, right? Rust, true and false values are written as true and false. Like, do we really need to say anything else here? Like, it's a Boolean. And the type is called bool. Right? Like, it has Booleans. We don't really need to go over Booleans. I'll give them their own heading because there's, you know, a thing to say, but we'll do arrays and tuples next. Arrays in Rust are fixed size collections of items of the same type, while tuples are fixed size collections of potentially different types. Right, primitive type array, fixed size, denoted like this. I think a small code example, and then we move on, more or less. Want an array that you can push items into. You want a vec. I feel like this is the biggest confusion that I want to clear up here. It's like there are arrays and vecs, and arrays in a language like JavaScript are like that growable array type. And the growable array type in Rust is a vec, and arrays in Rust are very specific. Like here's a 3-length array of F32s, right? This represents an XYZ value all the time. We do need links, I think, to array and maybe tuple if it's in the docs. I don't know. We have to have a page on tuple, right? What's wrong with that syntax highlighting? Anyway, tuple, this link, a finite heterogeneous sequence. Okay. I think that's even worse. I feel like anytime you get into language documentation, you end up getting like very specific, which is good, right? If I want to find out what a tuple actually really is, being specific about the terminology is good. But if I'm just introducing this to beginners, it's like a finite heterogeneous sequence is a lot of words to say. You can throw a couple different types in here if you want to. In your view, a tuple is just a struct with anonymous members. Yes, but there's also tuple structs, right? Right, like we could have let tuple equals like 1a, I don't know, stuff. But we could also have a struct that is I32 car string or something, right? And these two things, while being very similar, are not exactly the same thing. If only because you start one with the name of the type and you start the other with just the paren. Like effectively they're the same, but do they mention tuple structs in here? Converts a tuple struct into IP adder. I guess they are calling this a tuple struct, huh? Typically, this is referred to as a tuple colloquially. And if we look for struct, this is going to have, like, these are referred to as tuple structs. Why we've chosen to like differentiate the two, I mean, it's important because like you can't really impl for tuple, but I don't think it's enough to make a difference, except for the fact that like calling these two things different things aligns with what everybody else calls them. Data structures, arrays and tuples. Can't wait to get into error handling. I just inserted a chapter on scalars before the... Okay, arrays, tuple, structs and enums. So arrays and tuples. Arrays in Rust are fixed size collections of items of the same type, while tuples are fixed size collections of potentially different types. They use the word sequence. I like the word collection because collection is more general. We can use it to refer to more things, like vex and hash maps are collections. You know, why wouldn't an array or a tuple also be a collection? I guess we're kind of just introducing syntax here, which feels a little weird. I didn't really intend to get into like, here's the array syntax, but it's hard to talk about scalars without showing the syntax, you know? Like it's hard to talk about these primitives without just being like, this is what the primitive is. Because like, does this have a large impact on a high level for like what Rust is? Not really, but you do kind of need to know that it exists in some way. So I don't think that we will, let's do like a basic. I don't think that we'll have too many examples here. I think that we can do this kind of a thing. We'll use floats here because I think that having the differentiation between the like amount of number of things and the thing that is the default value are relevant. This, let's just do like 5 to 10 or something here. That infers as F64? Why does that infer as F64? I'm so used to everything inferring as 32-bit. I don't think I'll be able to find that answer easily. I actually don't even know if that is like a Rust analyzer quirk or not. Right, we've got empty array. And we've got XYZ. Both of these probably, or like XYZ is going to have to be a shared reference. And then we will do like XYZ 1. And running this will give us the empty array with 3 values, as well as XYZ with 3 values, and our ability to index. I think the ability to index is really what we need to show. We need to show that these are fixed length arrays. And then we can also talk about tuples in the next breath. I don't feel like this needs to be a super deep dive into like how to construct arrays, but just showing some of the syntax. I think you're used to game dev. The rest of the world uses double precision for everything. Really? Everybody uses F64s? It might just be that all my context is game dev and I'm so used to seeing F32s. But like the other thing is right, like the number 1 infers as I32. Empty array is a bad name. Yeah, okay, we can change that. The reason I feel like it should have been 32-bit is because regular integers infer as 32-bit. I guess if everybody else is using F64s and I'm just too deep in game dev, because like I don't use floats for anything but game dev, really. I mean, there's other reasons to use floats, but like if I'm dealing with Rust that's doing like a web API or something, I'm not doing math on floats. Embedded also uses F32. That's the other thing that I have going on behind the scenes. I think I show this every once in a while on stream, but I still have my little motor set up here with the breadboard and everything attached with my little embassy program on it. I have to get back to that at some point. It's just kind of, I haven't done enough on it. Let's do not empty array, but array of zeros. Array of zeros makes much more sense. Yada, yada, yada. Let's include that separation here so it's not just like a block of whatever. And recopy this output because the lines will have changed. Did we call that array initialization syntax? Does anybody else call it that? Arrays of sizes from 1 to 12 inclusives implement from tuple. I feel like I've never used that either. I never have a tuple of all of the same value. Is really what it is. Like I'm never returning a tuple of like 3 F32s that I need to turn into an array. If I'm going to return 3 F32s, it's going to be as an array of F32s. Slices, yada, yada. Couple of initialization syntaxes. I don't really want to cover all of these. You think you use it to convert bevy EGUI colors? Are EGUI colors tuples? Igui color is an array. Bevy color is like a nested struct. Or an array, depending. Right? At least a long time ago with some business logic magic that modifies the colors. Yeah, fair. Okay. So this is our array of zeros. Two ways of initializing an array of length 3. The first copies the 0 to fill all of the slots. The second uses 3 separate defined values, and thus doesn't need to specify how long it is. Array getting a single value from an array can be done by indexing. Then the output. And then we have like basically a similar thing for tuples, except we don't have the top version for tuples. So this just turns into like 5 hello and C, I guess. I don't know why I keep using C for character, but F64 string character. And then this is .1. Right. And then we get, this is not XYZ anymore. This is, I don't know. I don't want to use foo and bar. I don't feel like stuff is really any better. Let's just call it my tuple. Or tuple of values. Like tuple of values is weird. That takes up too much space for me. I don't want to call it, man, I kind of don't want to call it tuple because I feel like I'm going to confuse somebody by using the word tuple here. Call it values. Triplet. We could call it triplet. I think I'm going to go with values. Values is suitably generic. We probably don't need this type here, honestly. Like, it's pretty obvious that these are different types. But maybe it's useful. All arrays can only hold one type of item. Tuples can hold many different types of items at the same time. Here we have an F64, a string slice, and a character in a tuple. And then we don't need to use the actual signature here. Do we need the signature here? I feel like we kind of do need the signature here. Maybe we don't. Maybe I just remove it. We aren't really like being clear that this is then like an array of 3, but I don't know that we need to be that clear right now. We can kind of just say these have length 3. Here are 2 ways of initializing. Here are 2 ways of initializing an array of length 3. Yeah, I don't think we need the types there. The types are kind of inferable, and we mentioned them here. And then this runs, and we get these values. Did we talk about type inference? We didn't really talk about functions, which is usually when I do that. Let's see. RG infer. Where are we talking about type inference? Generics and traits. Maybe we throw type inference around somewhere. Rabbit hole, do at your own risk. Yeah, I mean, Rust type inference being so good is not something that is shared by all languages. We don't really talk about defining functions here because we're kind of just assuming that you know how to write a function. And if you know how to write a function, then every time we like write fn main or whatever, you're like, oh, that's a function with some stuff in it. So I think we'll get into like maybe functions deeper down here. We use closures and iterators, right? Ownership, some product types derive, pattern matching, function signatures. I don't know. Type inference. Maybe we do, maybe we don't. I don't know. It's kind of up in the air in my head right now. I feel like this document already being 4,000 lines tells me that it's already like a 10 to 20 minute video. So I think diving into too much more stuff than we have planned already is going to be a stretch. I'm gonna, after I finish scripting this, I'm just gonna run through it, recording it, not on stream, but and I'm gonna see how much time it takes me to just verbally get through it. And then once I verbally get through it, I can judge whether anything needs to be cut or added. It is a little bit tough. Let's see, what, like words per minute speaking average. 150. So we've got 4,500 right now, over 150. We're going to have to go at YouTube pace to squeeze this under 30 already. This is going to be a real YouTube video. What's up, guys? Burn. Video over. Never stop talking. Yeah, so we really don't have space to just like add stuff, I think. Yeesh, really? We have, technically speaking, already hit half an hour on the amount of content in this. And I really, really, really want this to be less than 30. Maybe when introducing let var equals something syntax, the type is optional and can sometimes be deduced by the compiler. Most of the time it can be deduced by the compiler. The only time it can't be deduced by the compiler, so to speak, is when it's ambiguous, right? Anyway, I have the note. I will find a place to fit that in because that's important. We've still structs and enums, error handling using dependencies, control flow, pattern matching, generics, traits, iterators, documentation testing, and how to read documentation. And we're already at half an hour and we have to cover all of that. Oh, okay. I might end up cutting this down actually. Creating your own data types can be done using struct and enum. This is how all of the data types we've used so far are built. A vec is a struct. A string is a struct that contains a vec. I forget what else we've done here. Maybe I TK this. Oh, result. We haven't gotten into error handling yet, but we're about to. This is such a weird sentence. This is how all the data types we've used so far are built. That's fine. That's enough. A struct is a collection of fields. An enum is a choice between multiple variations. We'll use variants. A struct is a collection of fields. Is that really how I want to explain that? Named fields, tuple structs, and unit structs are the three. Tuples, we still refer to those as fields, great. And then unit would be no fields, right? I don't want this to be too much syntax. I might end up taking out this whole section. You see Malek in the title? Where? On YouTube? What is the... In the thumbnail? Oh, did I use the same thumbnail? Damn. I used the same thumbnail, didn't I? I must have messed it up. We did that Saturday. Oh, wait, no. You have a browser extension, don't you? Yeah, you use a browser extension that messes with all the thumbnails. That's why you're seeing that. Because I use thumbnails that are relevant to my videos. And the thumbnail that you're seeing is like the first frame of the stream or something like that, or like a random frame from the first 10 minutes of the stream or something like that, which is not representative of what we're doing today. We did Bevy Malik async on Saturday. So at the beginning of the stream, I just mentioned that I updated the examples to do Tokyo multi-threading and let Tokyo handle the threads instead of spinning up a single threaded Tokyo in each instance. And I just pointed to the repo basically. That repo is in the Rust Adventure repo if you're at all interested, or Rust Adventure org. That is the Bevy Malek async demos repo. There's a couple of descriptions here for each of the binaries. The multi-threaded one is the most recent. I did that like after stream. The other ones are like the initial. Yep, absolutely they do. Also, the async library is so cool. It is so cool. The only thing that I'm having trouble with dealing with the async library is in one of those examples, which of course I just closed, right? So I can pull up my history. In one of these examples, I'm doing GLTF stuff. And the GLTF stuff, I have this loop here. So it just loops and calls async access. And this loop and calling async access is fine. It just checks every async access, which is inserted at specific places in the schedule. So like, I think pre-update, update, post-update would be where this is checking all the time. So for every frame, it checks like 3 times. But if you go to Bevy, it has an asset server, right? And the asset server has like wait for asset ID, which is async. Unfortunately, this takes a reference to the asset server. So you can't actually end up like taking advantage of this async function in combination with Bevy Malloc async. But I can rewrite this function. I can basically copy this function and make it instead of using self. So at the beginning, it says self.data.impose.read. This could be an async access, and then everything goes through here. And then there's some write and stuff. But just replace a couple of those calls with async access, and then it'll just work. But anyway, that's a little off topic. Can't wait to get sane async in Bevy. Yeah, the async working group seems like it's making progress, which is very cool. So very excited about that. Be defined as, what do they call these? Structs with named fields. They don't have a name for them. Why do we have a name for tuple structs and not a name for structs with named fields? Named fields. Unnamed fields. Or no fields. The latter two are often referred to as tuple structs and marker and unit structs. Unit structs is what we'll go with. So we need an example of each of them, I think. I'm trying to skip through too much of this, right? I don't want to spend too much time on like syntax and stuff, but currently running both a Bevy runtime and a Tokyo runtime and passes messages between them. Not really fun, but it works. Nice, yeah. Yeah, my concern about running the Bevy runtime and the Tokyo runtime at the same time was like if they would ever conflict if there was too much work. I want to ask Miles about that at some point. I feel like they've written about it already. But otherwise, I don't think it's actually that much of a problem. Because if it was that much of a problem, it would conflict with everything else on your computer too. What struct am I going to use here? I could say person. I kind of want to stay away from people stuff. Maybe we'll go with animal. What's a good name for an animal? Yeah, the load and the async runtime is relatively light. Yeah. You know what? Now that I think about it, it might not have been Tokyo. It might have been Rayon. That was an issue. And that's why Forte is being built. Vincent Van Dog. That's it. We'll use the same setup here, I think. I don't know. I don't want a U32 amount of legs. Thank you very much. So I'm going to leave it as a U8. What is it? Name, legs, color. We'll just leave this as a string for now because we're about to cover enums and then we can cover the combination of the two. Vincent Van Dog is probably multicolored anyway. It's like a smeary blue. Just some web transport hell. Yeah. Your dog made it to a Chris stream. Fergie, one of your cats already made it. Nice. That's awesome. That's the actual name of your dog. This is going in the doc. So you didn't just make the stream, you made the Rust educational learning material that's going to go out to a bunch of people. Let's name this struct is cool. And then this is my stuff, which doesn't need the type signature. And this is I32. Let's change this to F32 so it matches. And then this is a string, and this will be car. I'm trying to encourage people to use owned values in general. We haven't really talked about traits, but I think I will derive debug on all of these. Again, like this is not inherently meant to be like standalone in the sense that it can't be skipping around a bit. Millipedes offended. What do you mean millipedes offended? Don't they only have 100 legs? They don't have thousands of legs, do they? You'd want to have 32 infinity legs. You think they have more than 100? Should we... How many legs does a millipede have? Between 34 and 400. So more than 256. No millipede was known to have 1,000 legs until 2021. I don't know why that scares me more than millipedes not having. We'll make it a U32 for the millipedes. You know they only have 100, but the millipedes themselves think they have 1,000. They're proud people. Just imagining like a millipede just like gluing sticks onto its body, being like, look how many extra legs I have. Are they functional? No, but they look great. Centipede in French is mille-pat or mille-pat. Mille in French is 1,000, yeah. Why are these units? Hang on. 0 and 2 are never read. That's fine. Oh, they're never read, so it's telling me to replace them with unit? Oh, rude. It's funny that it doesn't matter that we have a debug here. It still counts as not using them. Pats is pawn? I don't think I've ever heard pats in French. Pats? Pates? My French is really bad. I'm trying. Paw. Or leg. Gotcha. Okay, so the run gives us this. I think this is fine for output. This is going to be kind of like flashed on the screen, more or less. Like, actually, we need it is cool to be flashed on the screen as well. So let's get that in there. Like, this is going to be effectively like one slide for the struct stuff, and I'm just going to rip through it. New question. How do you call that derived debug? This is a derive macro. This is a derive macro. Let's expand this. So we have this struct called animal, right? If we didn't have this debug macro or derive for the debug implementation, this call would not work. So if we try to run, and I save my file and run correctly, why did that run? Did VS Code not save this file when I saved this file? It doesn't auto implement. Oh, because animal.name. Sorry. I confused myself. We should do this whole thing probably, or at least like both of them, right? So, sorry. So we have animal here, which is a struct with some fields and some values, right? We can create an animal with those fields and values. So like name, whatever, legs, whatever. But we can't debug the whole struct because that uses the debug formatter implementation. We can access the values inside of it to debug them. But if we derive debug, then if I use my shared references correctly, then we can get the value printed out. So on the left here, you get the full printout of animal, and you can also access inside of it. Now, the thing that's happening here is if we go to Rust Analyzer and we expand the macro recursively, and I bring this up, this is the debug trait for animal. So the derived macros are really just code generation, specifically usually for trait implementations. Yes, the hash square bracket syntax is an attribute, which is like Java annotations. The derive is the built-in attribute that applies derived macros. Yes, that is all correct. So we end up with this code generated because if you look at this code, it looks very repetitive, right? You don't want to manually write all this code for every struct that you want to be able to print out in a debug setting. So there's a bunch of like functions you can use on this formatter to name the struct, to set the field values and stuff like that, and then finish the builder off. But this is kind of tiring to write. Like you wouldn't want to write, 22 lines of code every time you wanted to write this. So there's a derive macro, which you can use with the derive attribute. This works for a bunch of other things too. Like default has one, partial equality has one. Equality also has one, although it doesn't really do anything. It's just a marker trait. Ord and partial ord can go here. And if you really want to get fancy, there's actually a lot more that can go there too. Because if you go to derive more, there's things that don't, how do I frame this? There's things that the standard library doesn't provide derived macros for. But there are things that you might want to, specifically because there's a pattern called a new type pattern. And that uses tuple structs like we're talking about now, that wrap some value, right? And even though this is wrapped in myint, you might still want to use the add implementation whenever you have a myint value, but you want to use the i32 add implementation. So this crate allows you to do that. Basically keep your new type, which is just myint, which you can then gate functions on, right? A function can accept myint, i32 can be private, and then you can have only functions from your library can construct myint, for example. So if you have a myint, then you know that it was constructed via your functions and you know it was validated in some way. You can pass that to other functions, but then the code that uses it can add two of them together using the i32 underlying implementation. So there's a whole bunch of other traits that you can also derive, but don't necessarily make sense to have in the standard library. We haven't made it to traits yet. Traits are later. So all of that explanation is going to go into this document too. Let's see. I changed the output. So let's grab this code again and pull it back in. At some point, I want to write a typist tool to pull this from example files so that I don't have to like copy values in like this. Here are a few ways to construct struct values, types and values, I guess. along with the debug implementation, which we haven't really talked about yet. So I think this gives a pretty good overview for like, if you have a value stuff tuple struct value, you can have the whole thing, or you can access it by, dot index. If you have an animal, which is like a struct with fields, you can access the whole thing, or you can access a field by name. If you have a marker, you kind of just have the marker. So it basically adds behavior to data. Yeah, you can think about it like that. It's code gen for traits. So traits define kind of like the interface that a struct or whatever can provide. And the derive macros are used to implement those traits for those types. I forget what the function for add is called. It's probably just called add. But the debug trait requires that you implement a function called format, or FMT. So you can implement this debug trait for any type, but the common way to implement this debug trait is to write effectively the same code that you wrote for all the other debug implementations, which is why there's a derive macro for it. Tuple structs can be accessed by index. Structs with names can be accessed by field name, and marker struct, maker structs, marker. Did we call them markers earlier? I called them unit. Unit structs are zero-sized types with no fields. We can still debug them. Yeah, more or less, you can add behavior without traits. Traits are like an interface in a multiple dispatch case, more a concept in generics. Yeah. Yeah, you don't have to use traits to implement functionality for structs, right? One of the things that we do have to mention here is like impl make sound, or no, actually that's for a trait, sorry. Impl animal. And this is going to be like fn say name, right? And this will take self. And this will be a print line that says my name is something. And this is just going to be self.name, right? Animal say name. Talking animals is all the rage these days. So, along with the machines that we're raging against, we will also let our animals speak. So now I can animal say name here. And if I run this, my name is Vincent Van Dog. Vincent Van Dog? That's Xavier's dog. Xavier's dog made it into the content. So I think this is actually a pretty decent example of a function. We probably fn, we'll say die dog or die animal here. Mute self. And this will be self.color equals pink. Because, if you were going to dye an animal, you would have to dye it a color that is not natural, right? So animal dot die animal. This has to be mute now. And then we can debug animal and kind of show that the value has changed. Right, so now it's a pink. This is for both enums and structs. I think we'll mention it in the struct sense, and then we'll talk about enums. Must take Pantone code. Hey, if you buy me the books, I'll get a Pantone code. You know, buy me one of those big towers. Do we do impl before or after enums? I think we do impl probably after enums. Right? Because all right, we've talked about structs here. Let's talk about enums here. And then let's talk about associated functions. Do we want to call this? Implementations of functionality on a type, as if that wasn't generic enough. I don't know that I want to describe it like that. We'll talk more about impl for trade implementations. And this is technically like quote unquote implementing functionality for a type, but like they don't use the word associated at all in here, do they? I guess we won't either. Feels weird that they don't use the word associate in here at all. I guess they're called inherent implementations, although I've really never heard anybody call this an inherent implementation. Maybe I don't hang out enough with language people. I think we'll just call this impl blocks. Using impl block. I think I am going to use the word associate. So types defined as structs or enums can have functions associated with them using impl blocks. For example, we can take a shared reference to have the animal say its name. Take an exclusive reference to mutate these the values. To mutate the values. I think that's fine. You say explicit implementation and default implementation. You guess you need to correct that. I don't know that you need to correct that because I don't know anybody that uses inherent implementation. Maybe I'll search for that in a couple of the Rust discords later and see if people are actually like using that to explain what this is. In general, I don't see that really at all. Let's say there's also taking ownership here too, right? Self, self, and self. Do we have a candidate for taking ownership? I can think of one that I don't really want to use. I appreciate that the docs are explicit. So somebody said docs should use simpler words. I appreciate that the docs are explicit in the way that like programming language development can be explicit, right? One thing that I actually learned from like Haskell is, and from just like reading papers and stuff and other things, right? Every domain that gets sufficiently advanced develops its own jargon that overlaps with casual language. And the jargon for that specific area doesn't mean necessarily the same thing that it means in casual language. So I do appreciate actually that the docs are explicit and they use that jargon, because that jargon tends to have meaning in the domain. If you are outside of the domain, it can make it harder to understand, right? Maybe they need to additionally add like a casual explanation. Perhaps those jargon words should have a hyperlink to explain what they mean. Yeah, I totally agree with you. Like, it's tough for me to say which one goes where, because every resource isn't meant for every audience. I do think that the Rust docs could do a better job of explaining things a little bit more casually in addition to the specifics. But the reference docs are reference for a reason as well, right? If you're a practicing Rust programmer looking for a reference for what this thing does, then having the explicitness is probably good. Semantics. You're not an expert, but you deduced that giving good names to stuff is too much complicated for the human brain. Yeah, I mean, like if you are an expert in a similar field, then using that language really cuts a lot of the cruft out of communication, right? There are simpler cases, right, where somebody will come in to say the Bevy Discord or another Discord, or do XYZ and ask me something over Blue Sky or in person or whatever. And people who are new to things don't necessarily know how to frame questions because they don't know yet what they're asking. And that's kind of the same thing, right? Like somebody was asking in the Bevy Discord earlier, like, how do you bind a value to a shader? Or they said, what was it? It was like bind an object to a shader or something like that. And shaders obviously have bind groups and bind group layouts and stuff, but I don't really think that's what they meant. What they actually meant was, can you write a system to update a value in a material? So you can see how like someone outside of the domain ends up using words that overlap with things they're not actually trying to ask about. But two people who knew how rendering worked would know when to use the phrase bind in that sense. Or if they knew of bind groups, how to differentiate their question from being like about bind groups. So I don't know. It goes back and forth. I think that there's always a line to draw, and it's always in the wrong point for somebody. And not every resource can actually be the correct resource for every audience, right? Like a beginner resource and an advanced resource are not the same thing. Because if you include everything you need for a beginner for example, in an advanced resource, it's slow, right? Then the advanced user is just like skipping through a whole bunch of stuff. It's just like a slog to find the thing. If you give just the advanced explanations or the jargon explanations to a beginner, they don't know what to do with it because they don't know what those words mean. So there's always, documentation can always get better, which is one of the things I appreciate about the Bevy project. I think every time there's a docs PR, that docs PR basically lands. So that all to say, what do I do? What do you do with an animal that you no longer would have it? I really don't want to talk about death in a programming resource. Maybe just run away. Right. And then this consumed the value and it's no longer here. Set free. Set free is a good one too. Let's do set free. Shaders are not always doing shading. Back in the day, it was called a GPU kernel, but shader took the upper hand. Yeah, I mean, there's what? Compute shaders, fragment shaders, vertex shaders, technically mesh shaders, geometry shaders, et cetera, et cetera. Tessellation is a thing that people come in and go, how do I do tessellation? And like, you don't. We're going to use a shared reference to debug. Okay. If we're going to talk about Impl, I think we need to talk about all three of these things: shared references, exclusive references, and taking ownership. In Pokemon, use the verb release. Yeah, set isn't clear. I like the vibe. Let's call it release to wild. Why would that? So the comment is, if you want to feel unintelligent, go on Shader Toy. I feel like that goes back to the jargon thing that we were talking about earlier. The stuff on Shader Toy is a specific kind of shader programming with a specific setup. And anytime you go into Shader Toy or something like that, right? Cloudflare first checks you to see if you're a bot or not, which so far I've always passed, but who knows what the next one is going to come to. So I would also say there's a lot of jargon here, right? This is just some random demo. This is actually the shader of the week, I believe, which is a very cool shader. Very cool. But you have to know what a define is. You have to be comfortable with single variable, like constants. You have to be okay with single variable and like 3-letter variable names. You have to know what a float is, a vec3 and a mat2. You You have to know that rot is a rotation. What is G? Who knows? You know, like there's a lot of jargon here. And if this were written in a different way, it wouldn't necessarily be as confusing. It's actually all Cloudflare backed sites, I think. Cloudflare is doing something right now. I don't know what exactly they're doing. Somebody else said that they were potentially trying to prevent AI scraping. I haven't seen any official acknowledgement of what's going on currently, but I know that me and a couple other people that I've talked to are all seeing higher level Cloudflare checks than usual. But yeah, a lot of this it's confusing because it's concise and because it uses a lot of jargon, and because it does things in a particular way that other people who are doing this specific kind of programming, where you would program something to put on Shader Toy, with similar variables and stuff, like knowing ROT is a rotation isn't necessarily like that's jargon, right? Like this could just say rotation. It could be the rotation matrix, or it could be, you know, the function that applies the rotation matrix. There could be comments here. I'm not saying this person has to do that, right? But there's a big difference between the actual concepts being hard and it being inaccessible for other reasons, right? Very cool shader, though. I really like this shader. So, like, when you go to a shader toy, if that's making you feel like somehow not intelligent or something, it's not really because the concepts are hard. It's because, like, there's a door in front of you that's being placed there. If there was a table layout of like, here's what all of this means, you would find it significantly easier. I promise you. But that's just kind of like how some things are sometimes. Like if I jump into a new client's code base, for example, and they have tens of thousands, hundreds of thousands of lines of code, and it's a decade old code base or something like that, it's tough to get footholds in code bases like that, because a lot of the times they don't have comments, and a lot of the times even the comments that are there are out of date, right? But that doesn't mean I don't know what I'm doing. Right? Takes a shared reference to have the animal say its name. Take an exclusive or take. We'll do takes. That takes ownership and doesn't return the value, thus causing it to drop and be inaccessible afterwards. So I think if we're going to talk about Impl, talking about shared references, exclusive references, and taking ownership, that's all important and relevant. Yeah, or an old school person that learned C back in the day when identifiers were limited to 6 characters. Like there's definitely I don't know. I don't feel all that strongly about not using single letter names. I think single letter names can be really good for generics, right? If you actually have a thing that is generic and it doesn't have a name, like T or something can be a good placeholder. Like this is a type. It is defined by which traits it is required to implement. Therefore, it doesn't have a name. It is just a thing that requires these 3 traits are implemented. Okay, so impl blocks. Types defined Types like structs or enums can have functions associated with them using impl blocks. For example, we can define a function that takes a shared reference to have the animal say its name, takes an exclusive reference to mutate the values, dying the color of the animal, takes ownership, and doesn't return the value, thus causing it to drop and be inaccessible afterwards. These functions use shared reference to self and mute self and self, which all refer to the type that is the function is being implemented for. I think still for, even though it's not a trait. Like impl trait for type is very like impl this for that. But I think you're still implementing this function for that type. It's just not a trait. I don't think we need to talk about like empty argument functions or multiple argument functions. I think if somebody wants to write a function that doesn't take an argument that is on impl, maybe that's a bad idea. But you could definitely do it. I feel like impl blocks should really only have functions that use self, but that's kind of a personal quirk. I know that not everybody shares that kind of outlook. We do need an enum demo here. So we could use animal again. I probably already used the animal mental space from the person learning this. So maybe we do something else. Constructors, factory functions do not take arguments. You put them in the impl block. Yeah, new functions. Yeah, that's fair. That's very fair. I mean, I put them there too. I just try to avoid using them in general. Avian. Yeah, we also didn't talk about returning self with a capital S, right? But I don't know that we need to like mention everything here. This is just like an overview, right? So like missing a couple of things is fine. I don't strongly feel like we need to enumerate all of the APIs. I especially want to rip through this particular section. Swallow, blue jay. I don't know. What's another bird? I want to put physics here, but I like that would probably be too confusing. Not everybody's going to know what avian physics is. Types of birds. Yeah, the Buguriger. That's a bird that everybody knows, right? Bajuriger, but I'm not gonna get that one. Let's do chicken and owl. Let's get rid of swallow. Chicken and owl are super common. Maybe parrot is a good one. Animals, avian, chicken. Yeah. Late to the stream. Are we bird watching? Cool. Could you put this avian in a namespace to avoid conflicts? We do at some point here have to mention that one can contain the other. So I think we're going to have two of these actually. Parrots are red, right? Brown, red. I don't know. Blue chicken. We're not going to construct these really, so. So we'll start with colors. This will be our first example. I think this is our initial, like, hey, you can have enums. They can be green parrot, white chicken. Oh, if the parrot is called Jose, that would be two of your pets in a single stream. We might give names to the animals. We'll see. We have to do a combination. So maybe we have a bird struct and it has an avian type and it's got a name. We could fit your cat. We could fit your pets in. Anybody else got pets? And the output here. I feel like input output is so common that it deserves like a special kind of formatting somewhere. But in a PDF in a book, it'll be input explanation output, and in like multimedia, like a website, it could be like input output on the same kind of like two tabs or like something like that. Like, are you on a phone? In a video, you could put them next to each other. Like, here's the input, here's the output if there's enough space. So I don't know. It's a bunch of different things for different places. We'll find it. We'll figure it out. So an enum is a choice between multiple variants. For example, we can define a set of colors and then use a specific variant. This is great. This is great for when you have to pick one of many options. I guess technically speaking, enums are also a way to turn heterogeneous types into homogeneous types. but we haven't talked about how to nest yet. So maybe we don't mention that just yet. We do these, right? Color, brown, whatever. Avian is going to be a little bit more, I think. So let's start with colors. Outputs this. Impl blocks, we'll talk impl blocks immediately. Right? And then structs and enums. Hello, is that Mayu? Is that how you pronounce that? Okay. So enums get their little blob. Impl blocks get their little blob. Again, we're not trying to break down like the intricacies of the enum syntax. We are going to have to, how do I say this? So these are all like unit variants, right? I think that's the way that most people think of enums from other languages. So it's the right way to start to introduce this. But we do kind of immediately have to register that enums can have their own data as well. This is the color example showed off a set of unit variants. But enums can contain all sorts of data. And then we get away from color. Right? Maybe not name like that. Name would have to go outside. What would parrot have that wouldn't be? I don't want to get too deep into like the intricacies of birds. Like, you know what I mean? I don't want to make this like a whole section on like I have to explain what kinds of birds are like what other kinds of birds. They're kind of all the same from an enum perspective. They've got wings, they've got beaks, they've got feet, they can fly, or actually can fly. I guess flight distance, but that would be unique, or that would be shared. You think can can't fly is enough? I need something inside of the enum is the issue, right? Like we need like chicken, string, like parrot, name string, and like birds are kind of awkward for this. Maybe it doesn't matter. Maybe nobody cares. Maybe I'm thinking too much about this. That's possible. Chickens get IDs. That's what I've decided. Right? When you use unwrap, are you saying that like this is when you would use unwrap? Or I guess I'm not sure what your comment is about. We haven't used unwrap here at all. In French, chicken is jargon for somebody that checks IDs. Maybe I shouldn't have that then. It's like derogatory term, or is it okay to keep? I'll kind of rely on you to tell me that. If I feel like it's derogatory, so maybe maybe I don't use ID here. Maybe I use chicken number. We'll do chicken number, not ID. Thank you for bringing that up. Owl, print who. Yeah, we should do that. Yeah, that's so much better. Okay, so we've got our parrot here. If somebody wants to take this code and like run it, they can totally do that and mess with stuff. We don't really need these. This is why we do enums after structs, because specifically of the ability for enums to hold other data. Yeah, I think I can just rename the variable and it's fine. I don't think that it's not that important that I would need to keep ID there. It's just a number. And I just need to make sure that this is like an I32 and not the string that I had it as. And then it's fine. I guess we can mention structs and enums here then. If we're gonna make them that close together. then this can go here. Using this using structs and enums together can satisfy a wide array of data structure requirements. That's it. We'll just say, yeah, they can be used together because we've basically already shown how. You come from a Java background and enums in Rust feel very powerful. Yes. Yeah, that's one of the reasons that I want to mention enums and not just gloss over this whole section. Because what these are, well, I keep saying some in product types, but there's some in product types, right? So like you end up with a struct or an enum. The enums are a choice between multiple variants. Structs they have fields which can each have their own, numbers. So if you have a struct with like 2 U8s, you can have 256 times 256 values that can fit that type. Or like bool is probably better, right? Like if you have a struct, there's like my bools that is like A bool, B bool. Then every value that can fit inside of the struct is like true, false, false, true, false, false, right? Whereas a variant would be like, it can either be A or B. And you can just kind of nest these forever, which is great. In Rust, enums are like enums in other languages, but can also be like variants or tagged unions in other languages. Yes. If you use unit enums, you can go back and forth between like a U8, right? We're not really going to mention that here, but they do have as a discriminant. Like the discriminant still exists if you want it. So the question is, so enums are an ordered list of named structures. They're not really ordered. I see how you would say that because they like have a theoretical order like this. But these are not really ordered in this sense. They definitely have a discriminant, and those discriminant are represented as numbers, right? So like theoretically, this would be like 0, 1, and 2. Discriminant Rust. And you can get that discriminant in a couple of different ways, like casting, for example. You can also define that discriminant by defining it on the enum. This isn't really the page that I want. Standard mem discriminant is not really what I want. I want the reference for an enum, though. I don't want the book. Enumerations. Like this. So if you want to, you can specify these with any given discriminant. So these really aren't in an order, so to speak, right? Like you theoretically can get the discriminant, iterate over the discriminants, and then like make an order. but they're not inherently ordered, right? There's no real like relationship between these in an ordered sense. They're just IDs. And you just have to pick one is really all it is, right? So when you construct one of the avian values, you have to pick either a parrot, a chicken, or an owl. And you can't have multiple of them in the same slot, like that kind of thing. See, 10:30. We're doing well today. We're doing well. We wrote 1,000 words on stream today. Yikes. So for those who weren't here earlier, 4,500 words seems to be about half an hour at regular person speaking pace. I'm trying to keep the part that we're going over right now down to under half an hour. It's going to be tough. I might have to cut some stuff. Yada, yada, yada. I want to say this. I don't know if it fits. I think it fits. When working with structs, you can choose to define structs using owned data like string or references like string slice. When you're just starting out, prefer owned data almost always. This makes it easier to judge which variable actually owns the relevant data. Using references in structs can absolutely be useful, especially for zero allocation parsing and other use cases. Using references comes along with using references in struct definitions also requires more understanding of which variable owns the data and how long references live for. If you have an enum with an I8 and other signatures mixed, you can choose to only match a specific signature. If you have an enum with an I8 and other signatures mixed. Yes. These names are important. So if you have an I8 and like an I8, and like then we also have parrot. I don't know why these are I8s, right? But the names here are relevant, right? When you're matching on an enum, you're matching on those top level identifiers, right? We are destructuring here, like with the number or whatnot, and you can destructure further down. But when you're matching on this enum that you have, like this value, you're matching on avian chicken or avian owl or avian parrot. There's other things you can do in match that we haven't talked about, which are called match guards. So if you have an enum that is temperature with Celsius or Fahrenheit, I think this is, yeah, Celsius or Fahrenheit, and you match on that, you can match on Celsius. If the temperature is over 30, then do this. Temperature Celsius, do that. So if the guard passes, right, if it's over 30, then it'll use this branch. Otherwise, it'll use any other value that's left in Celsius. Same thing for Fahrenheit, right? If over 86, use this branch. Otherwise, use any number value. Maybe this one's a little bit clearer, but does that answer your question? When working with structs, you can choose to define structs using own data like string or references like string slice. When you're just starting out, prefer own data almost always. This makes it easier to judge which variable actually owns the relevant data. Using references in structs can be useful, especially for zero allocation parsing and other use cases. Using references in structs can be useful, especially for zero allocation parsing and other use cases. How do I want to frame this? I don't want to say using again. References in struct definitions also requires more understanding of which variable owns the data and how long references live for. I don't think we need to specify vec and vec. We're done with this. We're into error handling. We have accomplished error, made our way to error handling. So there are recoverable and unrecoverable errors. There are two major classes of error: recoverable and unrecoverable. These are represented by values. If the error is recoverable, or panics if the error is unrecoverable. These are represented by values is weird, right? Let's say if the error is recoverable, a function return a type that you can continue to operate on. I don't want to say error or anything specifically because there are functions on, say, vec, for example, like disjoint, split, mute, that give back errors. And there's also functions on vec that give you back an index, like a result of index. I forget what function that's called. That's like binary search or something. Right? Binary search. Binary search is a slice for a given element. If the slice is not sorted, yada, yada, yada. So given a sorted vec, or sorted slice, actually, this will either give you the index for the element itself, or in the error slot, it will give you the index that you could insert this value at, or a value that matches it, to maintain a sorted vec. So technically speaking here, I don't want to say that this always returns an error. Like if an error is recoverable, a function will return a type that you can continue to operate on. It doesn't necessarily return an error. It doesn't necessarily return a result. It could return an option. It could return a usize. It could return like anything it wants to, right? But you'll be able to take that value and do something with it. If the error is unrecoverable, the program will panic and exit. Now, technically speaking, when a program panics, you can catch unwind. But that I don't feel like is topical in this scenario. We could mention it. It might just be confusing. I think we're going to focus on the values. So let's start off with panics. A program can panic explicitly if something goes wrong using a variety of macros. Some examples include panic, to do, unimplemented, unreachable. I guess this is like a list, right? Panic, to do, unimplemented, unreachable. And assert equal that fails. I feel like it's important to mention like to do and unimplemented, because they're super useful when like just writing Rust, right? When writing code that isn't finished, it can be very useful to use the to do or unimplemented. We'll just say to do because we're implying that you're intending to finish it. So here we will say like to do, implement logging for parrots, right? We'll get rid of these numbers, and this can just be an enum of whatever. Does unreachable panic? Yes. Indicates unreachable code. This is useful anytime the compiler can't determine if the source code is reachable, yada, yada. If the determination proves that the unreachable is incorrect, the program immediately terminates with panic. The unsafe counterpart is unreachable unchecked. To do, implement memory for parrots. Yeah, all four of those are just shorthands for panic. Now, the thing that these do implement memory for parrots. What's that? Memory. Let's see. So if we run this, this will crash. That's intentional. And this will just be memory for parrots. So the general guidance for these messages is that it should just be the thing that you're going to do. Just like the general guidance for expects and such. Doesn't say start with expect. Let's do, instead of this, let's return a value here, because this makes more sense in the context. Right? So if this wasn't a parrot, if this was a chicken, this would run and it would say bird says chicken. I don't know why chicken says chicken, but maybe we just say squawk or something here. So the really nice part of using to do specifically is if this didn't exist, this is a compiler, right? And when you run this, it says match arms have incompatible types because avian parrot returns unit and these return string slices. So the really nice thing about these macros is that if you actually have to just like shortcut the type inference, you can do that. It will crash, right? Like we just showed. If you never hit it, it won't crash. But it short circuits that check. So now this compiles. And when it does panic, it says implement this. I think this is okay as a demo. Let's get rid of chicken here. When writing code that isn't finished, it can be very useful to use the to-do macro. This is effectively a shorthand for writing panic with a customized error message. When run, if the avian parrot match arm is hit, it will panic with the message not yet implemented memory for parrots. The other useful part of the to-do macro is that it will short circuit the type checking. I don't want to say type inference, I don't think. Allowing this program to compile. If the to-do macro didn't exist in this example, the parrot match arm would return unit. It's always weird to write unit inside of parentheses. Maybe I use commas. incompatible with the string slice returned from the other arms. We'll cover control flow more later. Meantime, understand that match expression like this must return the same type from all arms. We haven't covered control flow yet, so this is a little bit early, but I think we can get away with it because this is kind of the shortcut video. I think that's enough for panics. Like, panics exist. Some of the macros are useful. You can add messages to them. What else is there really to say about panics? I don't want to talk about catch unwind. Cool. So I think recoverable errors. The two major types used for dealing with recoverable errors are option. I'm going to have to go back through this document and add a bunch of links because I'm kind of just typing at this point. Option and result. They're both enums that contain a success value in one variant and an error value in the other. Maybe we want to actually show what they're defined as. An option represents a value that may or may not exist. Rust doesn't have a concept of null or undefined or other similar values. So option is how a potentially missing value is represented. And then we need result as well. While I'm here, I'll grab the link, but let's see, link, option, then we want results. Result. So we're going to grab this as well. We probably don't need to put pub here. We haven't talked about modules and visibility yet, so, you know, it is what it is. Result can hold any two distinct values in its variance. Result OK represents the successful value, while result error represents the error value. Often the error value in a result is an enum representing multiple things that could have gone wrong, but it is not required to be any specific value and could be a U size, for example. Okay, so We didn't mention unwrapping. Let's do maybe one or two demos, one or two examples of options. Let's compare index access. That feels good enough. Like that numbers equals vec 10, 20, 30, 40, right? And then this all goes away. And this is debug numbers dot get to, right? I don't want to use a number that already exists, so let's use 11. And this will panic. Nope, that's not how that's not how you write it to panic. Index on a vec. Get is, I'm looking for whether it's option or result because I never remember an option. Normally, if you do index access on a vec and you use an index that doesn't exist, the program will panic. There's an alternative function called get. We'll just copy this in for the link. There's an alternative function called get that will instead return an option This means the resulting value will be option sum if successful, and option none if not successful. The program above, for this program, prints out two values using get before panicking. How do you feel about panicking? P-A-N-I-C-K instead of P-A-N-I-C? I feel like CK whenever I'm doing panicking. This program prints out two values using get before panicking on the index access. Right, kind of drive home the point that there's ways to do things that panic and there's ways to do things that have options. And draw a line between that and kind of the larger scope. I think we're not going to have time for Azref. Again, this isn't going to be the deep dive on options, so I think we can leave Azref for like the deep dive chapter. This program prints out two values using get before panicking on the direct index access. What's a good result to use? I feel like the results for binary search are never what I want when I'm talking about this. We could use get disjoint mute error, which is fairly new. Get disjoint mute is a little bit weird because then you have to talk about like overlapping exclusive access. But this gets us to a pretty good point, I think, in that also option what is this? Options and results. I don't want to say they're isometric or whatever, or isometric, isomorphic. Options and results are so similar that it's common to convert between them by dropping or adding an error message. We've got okay and okay or, right? No, okay. I think it's okay or. So here we're talking about results, option, show some option. Link, get disjoint mute. Trying to use things that like use concepts that people are already aware of. Like we could use something that is just from a random library that does a specific thing. That might be a better example. But so far, we've really only introduced a handful of actual structs. Vec is one of them. If we can do something on a vec, then we're using knowledge we're using knowledge that we just gave to people earlier, and not requiring them to learn like a new structure and a new context to learn the new thing. So I do think get disjoint mute. Is that really missing? That's not missing the T, right? Get disjoint mute. Yeah, thanks. I was just looking at that going, that's really weird. That's what I get for typing things out instead of copying them. That's why I copy things so many times, especially when I'm dealing with actual named things. So I think the demo here is going to be pretty simple. This is going to be get disjoint mute like 0, 1. This is very obviously a mutation issue. And then let's let the Rust compiler tell us why I messed this up. Because it's an array or a slice. Yeah, there we go. Let values equals this. Values is a result of a slice of mutable references. So we'll start with the success, I guess. Let's do we haven't introduced let else syntax yet, but I think that's okay. So we end up with numbers that is 101, 102, 30, 40. This is the working case. This is just like used to be a very quick explanation for like what this is. Otherwise, it returns a, and then we're going to link directly to this error. This is going to be a get disjoint mute error. The function can give us non-overlapping indices or non-overlapping exclusive references to different items. And this is the output for that. But if we ask for the same item multiple times, we can't get multiple exclusive references to the same item. And we receive a result error disjoint mute error. Right? Disjoint, get disjoint mute error. And this is the value, so it'll be like that. And this is going to be overlapping indices, I think, is what we're going to go for first here. This kind of drives home a little bit of the idea of like, you can't have exclusive references to the same thing in two different places. And this function kind of encodes that in its usage. So it drives a little bit more home like Rust's ownership model implicitly. So we don't have to say all that much about it, but we already covered ownership. So this is like the next major time that ownership came up. So trigger it like this. This will fail. And I guess we could theoretically change the earlier one as well to the same structure here. So we have the same program twice instead of multiple different programs. I think that's a better idea. Get disjoint mute error overlapping indices. And then this doesn't have the final one, so we will, what do you mean replace with if let? Right, these are kind of unrecoverable in this sense because we're just using them so simplistically. There's nothing for us to really do. We wrote the program that accessed it, and thus that happened. And then these don't need to be debugs. So we'll put this here now. And then I think I can just swap this for 0, 1. And we get the output. And we'll use the same program. Rather than having two different programs and introducing new syntax, I like the idea of using the same program twice. Okay, let me take a look at this document because I haven't looked at the result here for in a little bit. Let's go to make sure this reloaded. Come on, computer. Oh, something here. Unclosed raw text. Thank you, types. On line 1056. Really? 1056, line 11? Hang on. What about new terminal users X Windows? This is 1147. Rust. Did I miss a quote somewhere? Is that what's going on here? Or is that like, does that need to be escaped? That would be really weird, right? On 1147, unclosed label. Oh, weird. Okay, so why is this an unclosed label? That's not great. I think that's a bug. One 47, not 1047. Oh, thank you. Oh yeah, but that was the whole thing, right? Yeah, 1056 is the first one, unclosed label. And I think 1147. I think that's just a consequence of the earlier. Let me put this over here. Okay, let's restart this. This has an unclosed label on 1056, which I think is triggering this whole issue. Let's make some of these minimized for a second. Okay, result. This. This is claiming unclosed label. Weird. I think that's a parser bug. It isn't happening here. So if I put a comma there, does it happen to option? Yeah. So for some reason, in a raw code block, open angle bracket, generic, comma, triggers typist label parse. And now we have a separate issue. On 1147, it claims this is unfinished, which means that this must be horribly broken. Right? All of my content here must be horribly broken. Let's go to Structs. Yep, we lose syntax basically immediately in Structs. So I must have not finished the animal one up here. Structs and enums. This is in Structs. This must be unclosed. Yep. Nope, not yet. Nope. Not that one. This one's okay. This was the issue. 794 had one open raw code. Yeah, it's a string as a struct. Yeah. Weird. So now does this still trigger? Because we should be in raw code there. Yeah. So this triggered because something before it broke. That's a really unfortunate error message, is what that is. I don't know if that tick can be used for multi-line code highlighting. But either way, that was just kind of really unfortunate. Okay, so we've got 30 pages, 6,000 words. Oof. Okay. Let's go to table of contents. Recoverable errors needs a heading. Okay, recoverable errors. Error handling. I feel like error handling needs to be like start of the next page kind of thing, but we'll figure that out later. Some PDF formatting needs to happen to this whole thing. So we've got recoverable errors. The two major types for dealing with recoverables errors. Okay, I need to do a spell check on this whole document. Two major types for dealing with recoverable errors are option and result. Let's see. Recoverable and unrecoverable. If an error is recoverable, a function will return a type that you can continue to operate on. If the error is unrecoverable, a program will panic and exit. Cover a couple of the macros. We don't cover the fact that unwrap can panic, but I think that's okay. Recoverable errors. Option returns a value that may or may not exist. Result can hold two distinct values in its variance. Authoring the error value in a result is an enum representing multiple things that could have gone wrong, but is not required to be any specific value and could be a U size, for example. I think normally if you do index access on a vec and you use an index, is normally is a weird word. I don't want to use normally. This means the resulting value will be option sum if successful and option none if not successful. This program prints out two values using get. Similarly, result is returned by vec get disjoint mute, which returns something that I need to add some ticks to. Function give us non-overlapping exclusive references to different items. Perfect. Small program. What if we ask for the same thing multiple times? Then we get that. Okay, I think this is pretty good overall. There's a couple of like, I'm just kind of writing, so I'm making some mistakes. I will need to run a spell checker over the whole thing or do a grammar edit pass, but I think it's fine. This needs to have that. There was one other thing that I saw, right, that I could fix quickly. Normally, I don't think. If you do index access on a vec, we don't need normally. Normally is a qualifier that doesn't need to be there at all. Just get rid of it. Get disjoint mute. References. Okay. Let's finish up the option and result. Section. We're looking for OK here. Link. Option. OK, or. God, I hope this is useful for people when it ships because, man, is this a lot of words. You know, it's like I'm kind of just using all of the experience that I've had from teaching people in the past to write out a new doc, but yeah. Options and results are so similar, it's common to convert between the two by dropping or adding an error message. Given an option, an error message can be added, converting into a result using OK or. Given a result, the error message can be dropped using link result. Okay. I think that's like important enough to note. I don't know that I really need to go into like a code example or whatever. It's just like a single function call. People can look at it if they want to. I'll probably show it on screen when this becomes a video. But this is absolutely like, I want to make it clear probably that these are like not special, right? They are like options and results are just enums. If you wanted to, you could do any number of things yourself, including like, for example, either, right? Either is just another enum. Doesn't represent success or failure. It's just another enum with a left and a right. Okay. We didn't talk about try, did we? I think we'll talk about try here. And then I think we're going to talk about anyhow. I think anyhow is more widely used. I like Miet, but do I really need to mention my favorite over a widely used crate? Not really. This error, definitely. Lib versus application error handling might get chopped. Levels of error handling might get chopped. This isn't going to be using dependencies. It's going to be like building our own errors, right? Or something like that. The sentence with get just try mute looks like a space where before the dot and not after. Yes, the code, if a code ends with a period, or a sentence ends with a piece of code at the end before the dot, it looks like there's an extra space in the PDF, and I don't know why. You can see it here on this little quick start thing here too. It's the name of our package will be quick start, space, comma. It's not really a space necessarily, I don't think, but something I can look into. Again, I have to do like a formatting pass and like turn these into chapter headings and things like that. But that's just not relevant for stream. Dealing with option and result is so common that there's syntax for return if the value has an error. This is called the try operator and can be used with both option and result, but not at the same time, I guess, or not. I guess it doesn't really matter that if you return a result, you can't question mark an option. This is not what I want. This can go up here. This is our new whatever. This won't be anything interesting, I guess. This will be FN above 10, let's say. And let's take a I32 and we'll return an option I32. And if number greater than 10, we will do sum 10, else none. And we're kind of doing this explicitly just to make it clear. This is not what I wanted to do, though. I wanted to do question mark error handling. So if we're going to do question mark error handling, I think we can do actually something very similar to the get that we did earlier. So let's do a numbers here of I32s, and we will return an option of I32s, I guess. And we will do numbers.get 4. And this function will be called add 10 to 4th index or something like ridiculously verbose, right? So let value equals numbers.get 4, value plus 10. So a little awkward. Let's say our numbers are a vec of like 1, 1, 2, 4. Let's not make the fourth index 4. Let's do like 10, 20, 33, 53, I don't know, 75 arbitrary numbers. Let result, let's not use a result. Let output equals add 10 to fourth index, numbers. Why we're using, a whole vec here instead of doing whatever, it doesn't really matter. Maybe I could come back and come up with a more realistic example. I also think that I'm going to keep this going for a long time. Like over the course of the next probably like 3 years, we'll say, until the next major Rust edition. I can still come back to this whenever I want and do little touch-ups to it so that it becomes a better and better resource over time. So maybe this example like works for now, isn't perfect, and then I come up with a better example later and I add it in. So 0, 1, 2, 3, 4, I don't know, 105. Yeah. Because otherwise, if the thing is too short, this is output none, right? So I think this is good as a short demo. Also one that doesn't require us to like build a result error type, because we're about to do that in a different section. When writing a function, let's go with if the types that we're using match, numbers.get or below. If the types we're using match, such as in the case of numbers get 4 below, then we can use question mark operator to unwrap the value if it's sum and return none otherwise. This function works on slices of length 5, fourth index, 0, 1, 2, 3, 4, or more, and returns none otherwise. Not a great example, but I'm okay with that. Building our own errors. Do we want to get into this error on this stream? It's not going to be a this error tutorial, right? I'm probably literally going to take the demo from the documentation and say, hey, if we want to make our own error, we can make our own error. There's a couple of things that this does for us, a couple of libraries for doing things like this. We're going to mention anyhow. I'll mention library versus application kinds of errors, right? You would use anyhow result in your application, but in a library, you might use this error return type. But it's getting pretty close. Could we crank out a little bit more here? There's so much more to write. Geez. I really want to get this video out this week. So this is going to be a tough one, but I'm going to write a lot this week. This is one of the largest videos probably that I've done in a while. Similar to how we saw, where's get disjoint mute error. Let's keep the link. Enum with multiple variants. We can construct our own variant, our own error types. Typically, this is made easier by by the crate ecosystem. Specifically, this error let's grab a link to this error. Let's link to latest for this error. That makes sense. Usually I try to do permalinks, like especially if I'm doing like a Bevy workshop. I try to link to the version of Bevy used, but this error, I feel like it isn't super important because we're not going to cover this error's like specific APIs necessarily. We are going to talk about the fact that you can create your own errors, but not the details of how to do that in this video. Snafu doesn't do that, right? I'm just going to check a couple others that come to mind. They use this error. Or actually, is that a comparison? This error is not necessary, but convenient. Okay, cool. And then Snafu, I think, is the other one that would... I don't use Snafu all that often, but I know some people do. Yeah, there we go. So specifically, this error is extremely commonly used to make writing error variants easier. There are also additional options like Snafu. We're not going to cover Snafu, I don't think. But I feel like mentioning it is worthwhile. So anyhow, error, yet, error stack, Snafu. Like there's so many error handling libraries. So is there a thing we can do here to make this more reasonable as an example? I don't know. I mean, there's almost certainly. I think that this demo specifically probably doesn't help all that much. It's kind of just the demo from the docs. It does show off some nice features, right? Like error message handling, things like that. But we're not going too deep into like how to do this anyway. So maybe we just gloss over this. Maybe we just say this error exists and you should use it. Anyhow exists and you should use it. When you're building your own error types, use your own error types from your library. When you're building an application, you can use anyhow's result types. And maybe that's it. Maybe, because I think going any deeper than that is going to be really rough in terms of time constraints. We can dive deeper later when we do a special chapter on, you know, building your own error types or whatever. I think I'm good with that. Okay, I'm running up on time here. I think that's it for the day. I'll be back probably tomorrow for another stream, maybe some Bevy stuff. We'll see. In the meantime, Discord is open for anybody that has Rust questions or just wants to hang out for whatever reason. And I will see you all next time. Sorry, Lon. I'll be back tomorrow morning. Have a good one, y'all.